We are here with our next speaker. His name is Kirk Marple from GraphLit, and who's going to talk about GraphRAG, more RAG for us. Over to you, Kirk.
Thank you very much. See if this works well. Yeah, no, thanks everybody for coming. GraphRAG has been sort of a kind of new hot button topic, but it's really been something from knowledge graphs and integrating RAG for different ways that we've been working on for a little while. So happy to talk about it today. So just 2 slides about what we do. GraphLit, we provide a conversational knowledge graph. So end-to-end data pipelines from unstructured data to RAG and knowledge graphs. We can use, really LLMs, NER APIs, any kind of technique to pull out those entities from your unstructured data and also be multimodal, which is really key. So we're basically an end-to-end platform for this. We'll kind of get into the details here. Anytime you have unstructured data, we talk a lot about data pipelines and how you kind of pull that data through to your end user. The end user is consuming that data typically through a RAG conversation, a prompt to an LLM, but it has to start somewhere. And so, really the left-hand side of the equation we talk a lot about is where's your data sources? And there's different platforms, different techniques for having data connectors to the sort of original data sources, which could be could be Jira tickets, it could be GitHub, Slack, or really any kind of file-based data, or even via web scraping. And pulling that through, there's always a kind of state of ingesting that data, kind of getting it from that source, finding metadata, say like your title, your author, your keywords, and even things like podcasts. They have episode numbers. There's a lot of metadata that can be found in the unstructured data. And you have to kind of follow the content through the pipeline to really get at your final capabilities for retrieval. And so all of this has to be integrated from the workflow engine, which could be called orchestration, the text extraction, embedding creation, and then obviously RAG and semantic search. But the knowledge graph at its core ties together 2 things. It ties together content, which is your media files, your web pages, but it also ties together the context. It's kind of what is found inside the data, not just a file name or not just the text. And that's really what we've been focused on. Is I really got started thinking about this as like a podcast discovery tool of, as you listen to a podcast, there's so much information that's kind of lost. Like you're hearing part like 5% of it, and the rest of it, you're like, I need to go back and find later. And I started thinking about, well, how do you represent these relationships of topics and people and papers? And knowledge graphs are a great fit because they tie those different pieces together of the person that you're listening to, that's the speaker, but maybe a paper and people they were on a paper with, and then topics. And so all of that fits together really well as a knowledge graph. And so that's really what we do. We talk about this whole end-to-end pipeline. And there's some things to consider when building a knowledge graph. Classically, there's something called named entity recognition, NER, which is really, it's giving you a term. It's sort of a lightweight text string that has a classification. It's a person, it's a place, it's an organization. But really, entities have more kind of meat on the bone. There could be like Microsoft or OpenAI, and what's its address? How many employees does it have? What are their revenue? And so entities have kind of more metadata than a lot of people think that isn't just the name of the entity. And so part of what you have to do when constructing a knowledge graph is pulling out this data as the full fidelity of the metadata that you can find. And LLMs are actually great at that. And so one of the other areas is, do you want a schema around the data, or do you just want to kind of treat it as JSON or CSV? We take a bit more of a prescriptive approach because there's something called schema.org you might be familiar with, or JSON LD, that's been around for a while. Google uses it for the knowledge graph. It's a standard taxonomy of people, organizations, places, and even subclasses. Things around healthcare, things around businesses. And we actually use this as our standard data model when extracting entities, because we didn't want to reinvent the wheel. I mean, this has already been around, I don't know, probably 10, 20 years now, and there's standardization already been done. And so we kind of say, look, let's map the data in the raw unstructured data to these schemas that already exist. And then really the other part is, I mean, LLMs, what we found when we started first testing this is LLMs are actually great at things like address extraction, where you have, I mean, a city, a state, a zip, a street, and then a company name, maybe on separate lines. I mean, separated by, punctuation, new lines. NER hasn't worked that great in the past for us for that, but LLMs can interpret that more complex data formatting and pull out what you need. And especially if you guide it and give it the schema up front, which is what we say is, look, find a JSON LD place. And here's the schema you're looking for, and it can give you back that data, it could form that data for you. And so we've had good success. There's a variety of different models that work differently. The GPT-4 class, the Anthropic, like Opus and Sonnet class models definitely work better for this, for entity extraction than like Haiku or some of the open source models. But then you run into token cost management, which entity extraction is actually very token intensive compared to standard RAG. And I think it's not an obvious thing that people really think about a lot. But I mean, we had a customer run up $1,000 in token costs in one day because they just sort of threw several thousand PDFs, I mean, like 200-page PDFs, and it did the entity extraction fine. It found thousands of entities, but it cost like $1,500. And it's something that you really have to be aware of, that knowledge graph construction. You want to do small scale testing and make sure you're doing it right, so you only have to do it once. Last thing we'll say, multimodal. This doesn't have to just be text. I mean, or doesn't have to start with text like a document or a web page. We can actually do a vision analysis on images and then take those descriptions or the OCR of the vision model and do entity extraction on that. So you might have logos or company names in a photograph or a picture, and you can then pull that into your knowledge graph. And so you just don't have to restrict yourself to thinking about PDFs or web pages in this case. And so we talked a bit about our schema first approach, and the entity types, I mean, we kind of talk about Google's paper, I mean, with things, not strings, very follows on this where it's people, it's places, we even do things like category, PII categories, and anything that can't be categorized is sort of a label. We still track it, but in somewhat of a generic way. And internally, we're keeping that metadata together as JSON LD in a NoSQL database. And so what we do is we have a hybrid of a graph database representation, which has the edges, the nodes and edges in the graph, and the metadata still in JSON LD form that is kind of the root of the entity that controls all the metadata about the entity. And here's an example. I mean, so I had worked at Microsoft at a time. The entity extraction had created a person and an organization and an edge between those. And the other really interesting part is after you've extracted your entities, enriching those entities adds a lot of value, and we'll talk about how that matters to GraphRAG, kind of incorporating RAG and graphs together. And this is where I think things get really fun, is entity extraction is interesting. You can create the sort of edges and the graph design, but it's when you can call out to external APIs and pull in data that wasn't in your original media. Like this is data that wasn't in your MP3, your podcast, it wasn't in the PDF, but you can then say, I've identified an organization, I'm gonna call out to another API to get more metadata for it, and then find a relationship which is sort of a hidden relationship that you've now unlocked that wasn't in your original data. And this could be like a CRM. You may be identifying data in a PDF file, you find a person and an organization, you call to your CRM and create that relationship and build your graph via internal and external data sources. And so what is GraphRAG? I mean, we kind of jumped ahead a little bit, but it's really RAG plus knowledge graphs. But what does that mean? We look at this as two ways. there is a way you can use the graph that you've built for filtering, or you can use it for greater context. And so initially, you can use the graph and identify elements in your prompt, find them in the knowledge graph, and filter your query, your retrieval step of RAG, to only things that are relevant that you for those entities you found. And I'll show you a picture of that. Or what you can do is do a standard RAG, but then walk the graph, the resulting graph, like the citations, and pull that extra information into your LLM prompt and give that to the LLM as additional context. And so we support both models. And finally, the one thing I'll say is GraphRAG we see is really as a pattern, not a product. They're really, you'll hear, I mean, Microsoft had a paper, I've talked to them about it. There's a couple other great vendors out here that are doing knowledge graph and GraphRAG. Neo4j is doing some stuff around it. But everybody has their own interpretation of how these things mix together. So the recipe might be different, but the ingredients are pretty much the same. And so here's a case where this is a prompt, and this is entities that I've extracted from this user prompt from, imagine a RAG conversation, identifying a person, an organization, and a place, and the edges. So the LLM can actually identify the relationships between here. And what you can do then is by using these edges and these entities as a filter, a pre-filter when doing retrieval, say we found here a PDF of like my LinkedIn that was exported and say a podcast I was on. And so this acts as an additional type of query and search to give you data to hand to the LLM to complete. Or what we can do is do a classic RAG kind of vector search where we're just creating a text embedding, finding the relevant documents like standard RAG, but we then take the resulting contents at the bottom and augment it with the graph. And so by taking you're starting with the vector search, doing a graph query, walking that graph, finding those relationships, and then giving it more data to answer your prompt. And what we kind of look at here is we follow somewhat we call like a prompt compiler model, where we give it instructions, we give it some guidance, and this is literally how the RAG prompt is written that we give to GPT, prior conversation messages, and then the content sources are filtered by the knowledge graph, and that's your text chunks, or you can augment it and give the knowledge graph entities with it as well. And so this all gets stacked up with the user prompt and given to the LLM. And what does that look like? So here's an example of, on the left-hand side, standard RAG pipeline. We had the same data, nothing changed. Ask, what is my relationship with Microsoft? It answered a couple paragraphs, a little bit thin, not a lot of detail. But then literally just by enabling that graph strategy for adding additional context, you can see it. I mean, it almost doubled in token size in what it output. And it finds interesting details where a lot of it came from the enrichment, because it's not data that was actually, say, in a PDF, it's data that it found related to that document that it pulled in. And we did a bunch of testing on this, and it seems to give almost more thoughtful responses. I mean, in a fuzzy sort of answer, but it really kind of gives more color to the RAG conversation. And we've had people test this and compare different RAG, GraphRAG, and they often say, I mean, it seems to give more thoughtful, more complete answers because it's seeing the bigger picture of the context. But what's the downside? I mean, this all sounds great, but it actually can be difficult to get a good quality graph. And what we've seen here is there also can be spelling mistakes. I mean, my name gets misspelled a lot. The company name gets misspelled a lot. Audio transcription is not perfect. OCR, there might be some pixels in there that you're not going to get the data from when doing OCR. What happens, because a lot of times you'll end up getting duplicates where, like, even in a graph demo that I have, my name is in there 3 times if we don't enable what's called entity resolution. And so this is another big part of, you have to have a good quality graph. You have to essentially clean the graph via some method. And part of this can just be removing duplicates, merging similar entities, finding kind of overlapping entities that maybe have the same name but different metadata. So it's classic techniques for entity resolution that have been around for years, but it's something really important to think about because it dovetails well into how good quality answers you're going to get from the GraphRAG solution. And then there are potential solutions of looking at clustering, using some third-party APIs. But really, this is where sometimes human review and approval is your only good answer. It may not be obvious to merge two names together. Like if you had a contact list, how do you really know if those are two different people or the same person? The human review side of this doesn't go away. And even the entity enrichment side of it, where you may want to automate part of the enrichment of the entities, but you may also want to require human review and approval. Okay, so wrapping up here. I mean, one of the big things we've been looking at is using LLMs for entity resolution as well, finding clusters of what seem like similar entities via vector embeddings. So actually using vector embeddings on the metadata for the entities, finding clusters of similar entities, and then asking an LLM to attempt to merge them. Or to say, oh, okay, I can merge these two, but split out this other one. It works, actually not that badly. We're doing some testing on it. I think it'll generate some better quality, but it's not a magic bullet. The other thing is cost reduction. The token usage, token intensity of this is non-trivial. It's something we're looking at. And then how to integrate with other external data sources, structured data, other graph databases, and import-export, obviously. You want interoperability between other knowledge graphs, which is important. And then better visualization and interactivity, because the human in the loop for creating good quality knowledge graphs isn't going to go away. And so I think be able to navigate through the graph, getting graph results, finding a subset of that graph, expanding that out into new content, kind of recursing down that is going to be super important for a lot of UX tools that are out there and applications you might build. And that's it. I think that's about time. I'm on time.
Thank you, Kirk. If we have 2 to 3 questions, there you go.
Yep.
Hi. What are some of the low-hanging fruit for use cases that graph RAG will kind of boost, and where do you see the main gains?
I think the biggest area is you have one corpus of data that is in files. And so say it's PDFs or it's web pages, things like that. And a second set of data that's in, say, a structured data source, like a database or a CRM. And I think be able to merge those two through the graph, I think is probably that's the most important area that I see. Because that data is not accessible just if you just are searching on the PDFs or that source. So I see that as being very interesting, where kind of you can start giving a way to get some structured data incorporated into RAG in an easy way and kind of chaining it through the graph.
Yeah. When using the graph for context expansion, how do you determine the depth of traversal to do? Or do you know if there's been like agentic work to dynamically figure out, hey, do I need to continue traversing or should I stop?
Yeah, it's a great question. I mean, we do sort of a first or second order traversal, so we're not going too far through the graph when we first pull that in. It's something we're looking at to see, how far do you really want to go? But we also have the way that, you could just call back and just continue to do queries and walk the graph recursively if you wanted to. I haven't seen any benchmarks on that yet, but it's a good question. It's something we've thought about of when do you stop, really? So.
Have you experimented with using batch inference APIs to try to reduce some of the token cost?
It's actually on our roadmap for next month. So no, it's definitely an area, especially with, when you're talking thousands of embeddings you're creating and be able to asynchronously do that, it's actually one of our big things to keep costs down, working on that next month.
How do you see knowledge graphs working with multi-agent frameworks? For example, if you have an agent that's its sole responsibility is to pick between a different set of agents, but depending on the data that they're connected to. Do you think that it could be helpful?
Very much. I mean, I think in our model, the graph is kind of global context for a lot. And so multi-user, multi-tenant kind of applications like that can share that state. And there's good and bad sides. Like when you enrich, do you want everybody to see that enrichment or just one user? But I think it's a great kind of context or scratch space for multi-agent and even multi-user applications.